Hello students, welcome to our online tutorial class. Today I am going to teach you chapter 10 from a science textbook, and the name of the chapter is Gravitation. In this video we shall learn about universal law of gravitation, importance of universal law of gravitation and free fall. Now when we drop an object from a height, it falls towards the earth. That means the earth attracts every object towards its center. Sir Isaac Newton said that it is not only the earth that attracts the other objects. In fact, every object attracts every other objects. The force by which two objects attract each other is known as gravitational force or gravity. Now let us see what is universal law of gravitation. Universal law of gravitation: every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay? So every object in the universe attracts every other objects with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the center of the two objects. Now suppose we take two objects A and B of masses m and m. One is capital letter M and the other is small letter m, and the distance between these two objects is d, small letter d. Okay? So according to the universal law of gravitation, force is proportional, directly proportional to the product of their masses, that is m into m. Okay? And force is inversely proportional to the square of the distance between them, that is 1 by d square. Force is directly proportional to the product of their masses and force is inversely proportional to the square of the distance, that is 1 by d square. Clear? Now, so combining 1 and 2 we get force is proportional to m into m by d square. Okay? So this is the product of their masses. Now, so F is equal to g m into m by d square, where g is the constant of proportionality and is called the universal gravitational constant. Okay? Now, multiplying crosswise we get F into d square is equal to g m into m. So, finally we will get the value of g will be f d square by m into m. So, g is equal to f d square by m into m. The accepted value of g is equal to 6.673 into 10 raised to minus 11 Newton meter square per kilogram square. Clear? Now, the importance of the universal law of gravitation. Okay? The force that binds us to the earth, the motion of the moon around the earth, the motion of the planets around the sun, the tides due to the moon and the sun. Now the next topic is free fall. So what is free fall? The falling of a body or an object towards the earth under the gravitational force with no other forces acting on it. Okay? So it's only under the gravitational force. The falling of a body or an object towards the earth under the gravitational force with no other forces acting on it is called free fall. Whenever an object falls towards the earth, acceleration is involved. This acceleration is due to earth's gravitational force, and therefore this acceleration is also called acceleration due to gravity. Okay? And so it is denoted by small letter g. Okay? Capital letter G indicates gravitational constant. Keep it in your mind. Capital letter G indicates gravitational constant. And small letter G indicates acceleration due to gravity. Now let us find what is the expression for acceleration due to gravity. Okay. So that is the calculation of G. Now according to the Newton's second law of motion, F equal to m into a. F equal to m into a. M is the mass of any object. Okay. So F equal to m into a. So we replace a with G. So it becomes F equal to mg. Now from universal law of gravitation, so the force is equal to G m by d square. Let an object on or near the surface of the earth, then d is equal to r. Okay, that is the radius of the earth. Now from 1 and 2, mg is equal to g m into m by r square. Okay, so from this we can find the value of g near the surface of the earth. So the gravitational constant is equal to 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. M, that is the mass of the earth, is equal to 6 into 10 raised to 24 kg. Radius is equal to 6.4 into 10 raised to 6 meter. So on substituting the values on the expression we have just found, we get G is equal to 9.8 meter per second square. Okay, near the surface of the earth. So G is taken as 9.8 meter per second square. One more point to remember is that the value of G is independent of the mass of the object falling towards the earth. This means that all objects, hollow or solid, big or small, fall at the same rate. Now, the equations of motion for freely falling bodies. Okay. So the general equations of motions are v is equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2as. So we change it to say a is replaced by g. Okay, a acceleration is replaced by g, acceleration due to gravity for freely falling bodies. S, the distance is replaced by height h, and the third formula v square equal to u square plus 2as, a and s is replaced by g and h. Clear? Now before we solve the numerical sums, some important points which we have to remember for the freely falling bodies. When an object is falling vertically downwards, g is taken as positive. When an object is vertically thrown upwards, g is taken as negative because it is against the gravity. When an object is thrown, when a body is dropped from a height, initial velocity u is equal to 0. When an object is thrown upwards, final velocity v is equal to 0. The time taken by a body to rise to the highest point is equal to the time it takes to fall from the same height. Now let us solve a numerical sum based on the motion of a freely falling bodies. The question is, a ball is thrown vertically upwards with a velocity of 49 meter per second. Calculate the maximum height to which it reaches and the total time it takes to return. Now let us solve a numerical sum based on the motion of freely falling bodies. The question is, a ball is thrown vertically upwards with a velocity of 49 meter per second. Calculate the maximum height to which it reaches and the total time it takes to return to the surface of the earth. So u, that is initial velocity, is equal to 49 meter per second and v is equal to 0, because when an object is thrown vertically upwards, so v is taken as 0, final velocity v is equal to 0. G is equal to minus 9.8 meter per second square. So this is negative because it is thrown vertically upwards against the gravity. Now calculate the maximum height to which it reaches. That means height, you need to find out height. So height is equal to question mark. So now putting all these values in the formula, v square equal to u square plus 2gh. Put the values, v is equal to how much? 0, u equal to how much? 49 square plus 2 into minus 9.8 into h. H is not given to you, h you need to find out. So we get 0 is equal to 2401 minus 19.6 h. So we will get h equal to 122.5 meter. Height is equal to 122.5 meter. Now the second question is, calculate the total time it takes to return to the surface of the earth. The total time it takes to return to the surface of the earth. So same, v is equal to 0, final velocity v is equal to 0, u equal to 49 meter per second, g is equal to minus 9.8 meter per second square, and t is equal to question mark. T you need to find out. So putting this value in the formula, v equal to u plus gt. So 0 is equal to 49 plus minus 9.8 into t. So gives 0 is equal to 49 minus 9.8 t. So 9.8 t is equal to 49. So t is equal to 49 by 9.8. So we multiply by 10 to remove the decimal from the denominator. So we get 49 into 10 by 98 is equal to 5 seconds. So time is equal to 5 seconds. So it takes 5 seconds to reach to the highest point. Now, so the question is total time it takes to return to the surface of the earth. So time taken to reach to the highest point is equal to the time it takes to fall from the same height. Is equal. Okay, so it takes 5 seconds to reach to that highest point. Okay, now you need to find out the total time. So time it takes to reach to the highest point and time it takes to fall from the same height is equal. So total time is equal to 5 plus 5 is equal to 10 seconds. That's all in this video. Thank you. Hello students, welcome back to our online tutorial class. In this video we shall learn about mass and weight, thrust and pressure, buoyancy, why objects float or sink when placed on the surface of the water, and Archimedes principle. First of all, let us see what is the difference between mass and weight. Okay? The mass of an object is the quantity of matter contained in it. Means the particles by which an object made up of. So that is the mass. Then what is weight? The weight of an object is the force with which it is attracted towards the center of the earth. The weight of an object is the force with which it is attracted towards the center of the earth. Clear? Okay. Then what is the SI unit of mass? The SI unit of mass is kilogram. Okay, the SI unit of mass is kilogram. And what is the SI unit of weight? The SI unit of weight is Newton. The SI unit of weight is Newton and denoted by capital letter N. One more thing is that the mass of an object is constant at all places. Anywhere you can take it anywhere or any other planet. The mass is constant, but the weight of an object is not constant. Okay? Because G depends on its location. G, that is acceleration due to gravity, depends on its location. Now the next topic is thrust and pressure. Let us try to understand thrust and pressure with an example. Suppose you stand on a loose sand. You stand on a loose sand. Your feet will go deep into the sand. Okay? Now lie down on the sand. When you lie down on the sand, your body will not go that deep into the sand. In both the cases, the force exerted on the sand is the weight of your body. Okay, when you stand on the loose sand, the force that is the weight of your body is acting on an area equal to area of your feet. When you stand on a loose sand, the force that is exerted, that is the weight of your body, is acting on an area that is equal to the area of your feet. When you lie down on the sand, the same force acts on an area equal to the contact area of your whole body. Okay, which is larger than the area of your feet. Thus, the effects of force of same magnitude on different area are different. Thus, the effects of force on same magnitude on different area are different. In the above cases, thrust is same. Thrust is same, that is the force is same, but the effects are different. The effects of thrust on sand is larger while standing than lying. So, what is the definition of, so we can say that thrust on unit area is called pressure. Thrust on unit area is called pressure. So, pressure is equal to thrust by area. Pressure is equal to thrust by area, and the SI unit of pressure is Newton per meter square, or we have another term for it, that is Pascal. The SI unit of pressure is Newton per meter square. We have one more term for it, that is Pascal. Now, the next topic is buoyancy. If we lift a stone lying at the bottom of the pond, it appears to be light as long as it is being lifted inside water. But as soon as the stone is lifted out of the water into the air, the same stone feels to be much heavier. This means that some upward force acts on the stone when it is immersed in the water, which makes it lighter. Okay? Now let us see, why do objects float or sink? When an object is put in water, then two forces acts on it. Weight of the object acting downwards and buoyant force acting upwards. Clear? So, if the weight of an object is greater than the buoyant force of any given fluid, then the objects sink in that fluid. If the weight of an object is equal to the buoyant force, then the object floats. If the weight of an object is less than that of the buoyant force, then the object floats completely in that given fluid. Clear? Now we can tell whether an object float or sink in a liquid by comparing its density with that of the liquid. An object will float in a liquid if its density is less than that of the liquid. Keep it in your mind. An object will float in a liquid if its density is less than that of the liquid. An object will also float in a liquid if its density is equal to that of the liquid. An object will sink in a liquid if its density is more than that of the liquid. Clear? So once again I repeat, an object will float in a liquid if its density is less than that of the liquid. An object will also float in the liquid if its density is equal to that of the liquid. An object will sink in the liquid if its density is more than that of the liquid. Then we come to the next topic, that is Archimedes principle. So what is Archimedes principle? When a body is immersed fully or partially in a liquid, in a fluid, it experiences an upward force that is equal to the weight of the liquid displaced by it. When an object is immersed fully or partially in a liquid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Clear? So, what are the applications of Archimedes principle? Archimedes principle has many applications. It is used in designing ships and submarines. Lactometers, which are used to determine the purity of a milk, and hydrometer used for determining the density of the liquid. So all these are based on this principle. That's all in this video. Thank you.